So, hello, thanks for coming to my talk here in the BSD Dev Room. Some people might remember last year me speaking about my engagement in speaking or in teaching BSD in my university, and this is the actual sysadmin part of my role there. So it's a nice combination because I can teach what I learned as a sysadmin, and vice versa. I can teach the students a little bit what's involved. So today I'm talking about migrating a big data cluster from Linux to FreeBSD, slowly but steadily. So this is going on for quite a while now, and I want to give kind of a status report and also a little bit how I approached the whole thing. This is what I'm trying to cover in the 40 minutes that I was given, and don't worry, it's a little bit more technical, and also a couple of social aspects are in there. So why this talk? Sometimes we get at the foundation or at the FreeBSD table downstairs the question of, yeah, I like BSD, I want to use it not only at home but also in my workplace, wherever that is, but I'm the only person using BSD there. I'm surrounded by other people who use other operating systems. What can I do? And so I thought, well, this is actually what I'm experiencing, or have been experiencing. So I thought, let's create a talk about this, and this is an experience report, basically how I approached it, and maybe you can get some ideas how to implement some of this in your own environments. Because we want to see BSD rising in the, not only in the private space, but also in the environments where you work or in the workspaces. So as I wrote here, there's no one true approach, so I have no master recipe to give you, but I have my story to give you, which is not also a successful one, but also fraught a little bit with peril. So it's not the perfect approach, but at least it's one way to get slowly but steadily a little bit better. So the first thing that you do is look around and learn, because if you're starting in a new company or are you with a company for a while, then you make a certain you look around and see certain things that you might like or certain things that you don't like, and maybe you figure out, okay, this is where BSD would come in handy in this area. That is basically making a list of things that you want to change. So I use it also to describe to you what the environment is that I work in. And yeah, so this is the first slide here. So one day I inherited a big data cluster at work. So I started there, and a colleague of mine had actually started this big data cluster project that they started from the need that the students wanted to do long-term measurements of performance, like for an NoSQL database benchmarking or a thesis work or just projects that they were doing. And so they were granted a couple of machines as called a big data cluster. So it's basically a rack of machines. I have a picture in the next slide. And so they built it up. I wasn't involved in that part, so I basically had to take what they left me or what they gave to me. And so I took over this. This is the big data cluster, it's called, and it's used in the University of Applied Sciences in Darmstadt, Germany, where I work, in the computer science department, although nowadays the whole university can use this cluster. And the person that initially administered was a Linux person. Oh, how new is that? And was using Ubuntu at home, so he thought it would be a good idea to use Ubuntu that he knew in this cluster as well. And so this might be one of the first mistakes that were made, but I'm getting to that. And so this is an all Linux environment. So actually the whole university is mostly Linux, or the computer science department. A couple of people are now getting more into the BSDs now that I did a little bit of advocacy work. But basically back then, this is a couple of years back, there was no BSD at all. Maybe me running this as virtual boxes or teaching students to use BSD in my classes, but that's pretty much it. So the OS image that they were using was based on the actual computer lab machine image, which is kind of weird because this is a server environment and lab machines are typically sitting there waiting for students to do some work on them. So lab machines are typically more desktop oriented, and the image is also desktop oriented. I don't know why they choose to use that on the big data cluster, but I'm getting to that later on. And then the classic thing, operating system on the first disk, and the next three disks that are in each of those nodes are used for the NoSQL database data files. And they also bought a central file server for exporting the home directories for the students and the professors via NFS3. So this is fairly straightforward and fairly easy to use. So here's the little for the graphics or for the hardware geeks here out there. So this is what we use. So we have old nodes. These are the ones that I started with. So this model, the C6220s, aren't even on sale by Dell anymore because they went out of support a couple of years ago. And we're now using the next generation models, the C6320. And so it's basically 64 gig RAM machines, 8 CPUs, and 4 hard disks. That's pretty much it, what we're working with. And so some of the newer nodes have a bit more memory and a couple of newer modern processors, but that's pretty much the only difference. And the file server is a little bit less in the memory area, which is kind of bad if you're thinking about using ZFS later. But pretty much the CPUs are there with enough power, and they have enough disk space to cover the computing needs or the NoSQL database needs that we have. So the software in use when I took it over was basically a Hadoop installation, and they were using also Pig, which is kind of accelerating the Hadoop queries a bit. And Couchbase was in use, MongoDB, and nowadays we're also having a Spark installation, which has a couple of other components in there. So this is basically all in the area of big data and data analytics. And we have a study program now with the mathematics department, and that's called data science. So the student can take that 4-year or 4-semester course and become data scientists. And they're using the cluster basically for lab work, thesis work, or project in this area with companies, for example. And so then I looked at, okay, let's look around what actually is supported on FreeBSD. So is Hadoop supported on FreeBSD? Answer is yes. And I wrote about this in the FreeBSD journal a couple of months ago, how I use FreeBSD and how you can deploy FreeBSD or Hadoop on FreeBSD with ZFS, because the ZFS part makes it actually interesting. Couchbase itself has no native BSD client. There's only libcouchbase imports, and there's nothing to download on the manufacturer's or the vendor's website. So that needs a little bit of porting help. I see a couple of porters in the back. Maybe that will be a thing to work on. MongoDB, there's a port available, but it's not the latest version. So currently there's 4.0.5, and in ports there's version 3.6. And of course, the researchers and the professors in my university are always interested in using the latest versions. Not that they want to use it every semester, the newest version, because they usually also want to make sure that their slides are staying valid for a couple of semesters. So, but in generally, if you are writing research papers, you always want to test with the latest versions of the software, because otherwise they will not accept your paper or laugh at you. The Spark server itself, we started that last year, and that's kind of involved. The actual playbook that I wrote to deploy this has actually over 180 steps. And you can imagine how complicated it is, because Spark also includes the Hadoop installation, and so there's multiple dependencies there to make it all work. Okay, so how do we start basically, or what's the environment that I'm also working on? So education is an interesting place to work in that there's no production environment, or the production environment is less important, you would say, than in a commercial environment where you have to have 24/7 uptime and all these things. So my production environment usually only lasts like one semester, which is like 3 to 4 months, and then I basically can reinstall again, because that's all the software being used in the next semester. So I only have to take care of the software for like 3 months, and then let's reinstall the whole thing again that I made so much work on to make it running. And so lectures, as I told you, they tend to stay with older software versions a little bit longer, unless they're doing research. In that case, they need the latest and greatest versions of the NoSQL softwares. And the production, again, is only the time frame when the student's doing their labs, which is typically 5 to 6 times, and then the other week is the other group, so we have typically 2 lab groups. And the cluster makes it actually easy to not be bound to a certain lab, because they can use SSH to connect to these machines from home or wherever they are, and don't have to be at a certain lab in a certain hour, and can only do it for like an hour and a half before the next class starts. That makes the cluster relatively flexible in its use, and the popularity, since we have that, introduced. It's very popular because students see that they can run a lot of beefy benchmarks on that, or make a lot more CPUs spin than they have at home. And so the problem was when we talk about installation life cycles and updates, that we also have to make sure that the operating system supports the NoSQL databases. And so for the longest time, when they were still running on the Linux side of things, they were running on the Ubuntu 14.4 version, and we couldn't get to Ubuntu 16 or 18 today, because for the longest time Hadoop had a problem with Ubuntu 16. You couldn't run a Hadoop cluster on Ubuntu 16. That was the vendor trying to get it working, and we were just waiting and waiting, and nothing happened. And so the students kept asking, hey, can I upgrade this thing? I want to use the newer version of Ubuntu. And I said, well, if you want to use Hadoop, there's no chance. You can try it, and you would help me actually make it work. But several students tried and never got there. And then someday Hadoop folks got it working. I don't know what was the showstopper there. But then we could update to the latest version. So on FreeBSD, no problem. Latest versions perfectly supported, no problems. But other software was kind of difficult in that regard, because it was always just available for Linux, and BSD is not even a download option on their website. So that's a general problem. And I also give away these lab machines or these cluster machines to students to do their thesis work on. And it's always, okay, dear student, what do you need as an operating system? Well, I use Ubuntu, whatever, at home, and please install this on the cluster. Okay. Sometimes I tried to install FreeBSD for them and then asked them, or gave them access to the node, just to get an email 5 minutes later, oh, I don't know this operating system. Can you install Linux for me? Okay. But a couple of people tried, and they actually did their thesis on those machines, and yeah, even on FreeBSD, because what they're mostly running are applications. They don't care what operating systems are running on them, and that way I can introduce FreeBSD a little bit on the sneaky side. And some people just want to run their databases and don't care what kind of operating system is running below. Okay, so that's what the environment is that I'm working on, or what I've been trying to make changes in. And so the changes have been coming slowly but steadily. So the rationale here is I don't want to just introduce FreeBSD because I like it. I also saw a couple of things where FreeBSD could actually improve things or make things better. And that's why I try to bring FreeBSD in this environment and create something valuable for people, so that they don't, maybe they don't see the features, or I've never heard about the FreeBSD features. And that's why I try to introduce this and told them about the cool features, for example, that ZFS provides, or that Ubuntu or that Hadoop is running quicker on ZFS than on Ubuntu with a traditional ext file system. And so the thing that I told you about at the beginning, that we were using the actual lab image for the cluster, which is more as a server environment, that includes we get the whole desktop craft from the labs into that environment. So I had printer drivers on a server. I had graphics drivers, sorry, Nicholas, on a server that will never run anything graphical because you need the CPU power to do the actual benchmarking. And so I took that image and actually was cutting and slashing stuff out of it which I don't need, and that actually reduced the install time of that image from 25 minutes to 11.5 roughly, and I think I can cut this down even further, removing more Linux stuff that we don't run on the cluster anyway. And the FreeBSD install itself just takes 3 minutes, probably less if I can tune it a little bit more, because the only thing that I need is basically get the OS running, partitioning and ZFS setup and all that, and set up the networking and maybe some LDAP so that the students can log in with their student ID, and that's pretty much it. Then I reboot. I don't have to install software in this part. I can install software later using Ansible or other software distribution, or just package install. That's pretty much it. I don't need this as a full big image that I have to copy over the networking to the node, which actually creates already some value because install times are going down. The nodes are available faster again. If a student is finished and the next student is already waiting for that node to become available, I can say, sure, in 25 minutes, or now in like 11.5, you can have the next node available, because that's the install time that it takes. And if I'm testing things and I need to reboot the machine because I totally messed it up, and then I have quicker test cycles this way. So first steps, if you're in a new environment and want to try out FreeBSD, and maybe it's a hardware or a hardware environment they've never worked on, is the question, of course, is your favorite BSD working on this? It doesn't have to be FreeBSD, it could be other BSDs as well, but I want to use FreeBSD. And so after the first boot, I was kind of encouraged because a lot of devices were detected, and because FreeBSD is the actual server, that's where FreeBSD is coming from. It's a server desktop, or server operating system, and there's a lot of drivers available for these bigger and more expensive hardware parts. And then the question is, well, I can install it, but does the machine actually reboot into the new operating system, or is it just forgetting about bootloaders and all the other things that are required? And luckily it did. So then I knew that this machine could run FreeBSD. Then what I did was quickly start a process to automate the whole OS installation. Because as much as you like your favorite operating system, there's nothing more boring than just installing it all over again, just clicking the same prompts, entering the same information all over again. And so that's the first thing that I did, trying to create this little ISO image that's completely automated. Just load it and let the machine boot from that, and it automatically installs, and you just have to watch and drink coffee. And so also, network setup is a bit interesting in the university environment. We do a little bit of IPv6 there. We also have a couple of things where we try to separate networks from the students so that they don't break into, I don't know, our central servers and change their grades or whatever. So there's a separate network for the big data clusters, and it's also a bit secure this way. And we have an LDAP server, as I mentioned, that is providing the whole accounts for the department and for the students, so that the students don't have to create their own accounts and remember their passwords all the time. So it's just one password they have to remember. And of course, the NFS setup from the central file server to mount the home directories for the students, and that is imported from them, and then they have every file that they have in the home directory on each node that they have access to. And of course, I could reuse all of or many of the things from the Linux desktop environment that they provided initially, but I just had to move that to BSD, where paths are different, or there are some Linux-specific things that don't work on BSDs, and that's the actual first steps that I took to create a node that is complete FreeBSD node. And we're still not talking about the applications running it. This is just operating system and networking. Okay, so then we need to tackle bigger problems, because then we have already established some kind of foothold on the cluster with the BSD. You know that it's running, and then the question becomes, is the actual software that the professors are using running on that environment? And again, this I get a lot, the first sentence here, well, actually we don't care where, so this is the database group where the cluster is located, and they pretty much don't care what operating system they're running on, because they're mostly focusing on the database side and don't care what operating system is running below. And as long as their favorite NoSQL databases are working, then they can just do their benchmarks and whatever they need for their research purposes. And so the question is, why are they not just running everything in Beehive? Because then you can have a bit more flexibility and just providing Linux machines that are actually running on a FreeBSD environment, and you just fake that there is a Linux distribution in there, and they are just running their same environment that they are used to. And that could be done. The problem is that the professors actually, or the students that are working on that, are actually doing performance benchmarking and creating papers and thesis work. And as much as I like Beehive and its performance or its thinness in the layer between the operating system and the virtualization, there's still a little bit of overhead. And that little overhead can be seen in benchmarks, or could be seen in benchmarks, and that might skew the results a little bit, so it's kind of difficult to say, okay, let's fake everything in Beehive. Overall, we had used Beehive a couple of times because, as I said, the cluster was becoming very, very popular, and a lot of users wanted to use the cluster, and I said, oh, sorry, I'm out of nodes. I don't have any nodes left. You have to wait until the next student is finished with his thesis or her thesis. And so what I tried to do is give everyone a little bit of space on the cluster in a little Beehive, because they don't usually run everything on all nodes, or only need like 4 CPUs instead of 8, or only 16 gigs of RAM instead of 32. So I could try to partition this a little bit and That worked a little bit when we were in the situation where a lot of students wanted to do the data science labs, and we didn't have enough nodes left, so I had to create a couple of beehives to make that a little bit better, to allow more users, because we want to let the users use our node or our cluster as much as possible. Okay, so that's the research part, why we cannot do the beehive thing. The other thing is, you saw that there are 4 disks in there, and it's immediately clear that everyone says, well, of course, I created RAID Z, RAID 10 on that, and perfect, over 4 disks, that's a good performance boost. You also would get ZFS compression and all the other things to manage your I/O better, and all the cool things that Alan Jude could probably talk about. And of course, you would also use a separate data set for each NoSQL database. It's much more flexible. You have much more ways to manage your storage this way. Problem is, same argument, when they do scientific measurements or writing papers, apparently if there's a RAID layer involved, somehow then the papers that you are submitting are flat out rejected. The paper committees just look for, not just looking for that, but if there's a RAID layer somewhere, if it's a hardware RAID or a software RAID, then they just say, well, it's all the benchmarking results are the result of the RAID layer and not of your tuning mechanisms in the database layer. And that was kind of a bummer for me, because I really wanted to introduce ZFS into this environment, because I think the professors would also like that. And but when they have to do this paperwork or this research paper things and are rejected from conferences, we didn't have that yet, but that's the downside of this. If they wouldn't do any benchmarks, then it's perfect. It's the environment we're probably going to use. And then I'm always thinking, well, if the paper committees reject those papers, then how realistic or production ready is this kind of setup? Because then you could say, well, if you cannot do a RAID, then you just have to use a single disk. But that single disk will fail. I mean, the disks in our cluster are like 5 years old now, so I just wait every hour to get a result from the smart CTL to tell me that the disk has died. But is this actually, I mean, this might be good for research, but is this production things that we're talking about here? So I'm kind of a little bit on the edge about that. Okay, so next thing.
It's probably for comparison, because if you introduce different RAID setups and then do optimization on top of that,
right? So
it's hard to decide where did the performance really come from.
Yeah, the comment was here that the comparison is difficult if you have different RAID setups and different RAID levels for comparison. Okay, so now we have a FreeBSD, a couple of FreeBSD machines in there next to the Linux machines that are already running the old kind of hardware and the old kind of software stack. So now let's grow and extend a little bit. So the biggest issue here is the file server. Oh, we don't only have nodes, we also have a file server. And since the file server has been serving these home directories to everyone and the research data set, I mean, we have a 370 gigabyte JSON file to load into the NoSQL databases I mean, it compresses super well on ZFS or on, gzip, but they always have to ship the 300 gigabytes JSON file from one machine to the next to load this into the NoSQL databases and then do some kind of schema management, or I have no idea what they're doing. But it's, 370 gigabytes of JSON. Okay. And the file server is basically providing all these data sets, and welcome to the new world. So since the file server has been serving all these files all the time, there was no time to actually make an upgrade of the software and to the actual operating system bits. And again, the file server wasn't set up by me, and what they did, they basically did a BIOS RAID 5, so this is a hardware RAID 5. And oh my God, I wanted to run smart CTL on this thing, and it gave me nothing because it couldn't look into individual disks made up of that RAID 5. So I had no idea whether these disks were all dying or whether they are healthy. So I did only see this one big blob of storage that they were providing down from the BIOS to the operating system. And there was one issue from the start. There were always, so you would create a file on your home directory or on the file server shared, and it will always have strange permissions. You would get permissions like suddenly you had permissions that the dean was actually owner of that file, or that the secretary was the group of this directory. And I was like, where is this coming from? I mean, all the data is provided by the NFS or the LDAP servers. The LDAP has all the group information and the group sizes or the group IDs. Why are they so wrong when they just touch a new file? And so after a while of looking at this, I traced the problem down to the etc add user conf on Linux. FreeBSD doesn't have that file. Maybe that's why I didn't find it right away. And in there, you have a value called first UID. And if you're on an LDAP setup, you need to increase this a little bit so that the local accounts are distinguished from the ones provided from the LDAP server. And my predecessor didn't know about this, or at least didn't do that, because the timestamp on the etc@user.conf was from the date when the server was installed. No changes since then. And once I bumped this, all the files that were created had the correct ownership and permissions. But you can imagine, this was like 5 years into the big data cluster is live. I'm not going into each individual's home directory and changing permissions that way. So I thought, okay, this is a failed experiment. Let's reinstall the whole file server. Otherwise, we're just coming into problems again. And again, I didn't like the hardware rate, so I always wanted to use ZFS for this. So I made a move into reinstalling the file server. Oh, here's the first picture, by the way. Woo! Yeah. So the process of migrating the file server was actually quite easy. So I said, okay, one of the nodes is now becoming the new file server, because I couldn't reinstall the file server in place, even though we had relatively large semester breaks, so where this could be possible. But even during the semester breaks, there were students writing their thesis on them, or professors were doing projects on that. So it always had to be something going on the file server. So I said, okay, now I take a node from the cluster and I install it the way I like it, like with ZFS, and test all the things that I wanted to have that the later file server was going to become. And I copy all the data files over and create the mount points for the students, and then let this run for a whole semester. So this file server was actually offline, no one was accessing it, and they were just making all the calls to one of those nodes, which was now the new file server. And then during that time, there were some issues or some things where students were confused where their files suddenly ended up. But all these things went into basically a little file where I wrote down things that I needed to change or to make adjustments for the actual file server installation. And once the semester was over, which was pretty much painless so far, I mean, there were a couple of things but those were easy to fix. And encouraged by those things, I did the actual change to actually now say, okay, a big announcement to the whole department or the whole users from the big data cluster. Next week, we install the file server. And surprisingly, no one else was complaining, because they were actually using this one node that I dedicated as the new file server or the interim file server. And they said, yeah, okay, I'll give you 1 day, and if everyone is complaining, then, well, we still have the old data on this one node that I used for it. And so one day, me very excited, going into the server room, getting in front of the file server and removing the old Ubuntu installation and booting FreeBSD for the first time on it. In which case I removed isn't it the nicest thing to just go to a server and remove the hardware RAID without having to worry about the data on it? So that was cool. So what I did is I created individual for each disk. So we had 24 of those in the file server. So for each individual disk, I created a RAID 0, because you couldn't do a no-op export into the operating system. So so each disk has now is in a RAID 0 configuration, exporting itself to basically the operating system. And ZFS will basically pick that up and create a pool out of it and the data sets on top. And ZFS installation went pretty well. In its course, I discovered the amazing MFI util. So that's basically managing all the things on the operating system side that you would only do from the server BIOS. And there are utilities to like check each individual disks or run periodic checks. And that's a very powerful tool. And of course, then after I was happy with the configuration and the file server setup that I wanted to have, I copied all the data back from the node that was currently serving all the files, and then said, well, thank you, dear department. Now we have a ZFS-based file server that I immediately saw the compression ratios, and I was like, yes, so much disk space was saved. And yeah, everyone was interested in that, and I told them about, of course, the other features that ZFS has, quotas and reservation and all the other things, because that's actually the interesting part. Then the students don't overwrite their own home directories anymore, and I can limit the students to only, say, like 2 gigabytes of disk space that they're allowed to use, maybe 4 if I have a good day. But yeah, that's pretty much the actual migration. I'm pretty happy that I could make it work, because the operating system on the file server is really getting old, and I was worried that someday someone might be hacking that thing. So I'm not actually too worried about external attackers. I'm more worried about the students in computer science trying to do, oh, what's this utility doing? And oh, now I have a cluster machine on my control. Yeah, not gonna looking good. And then this is our new setup, so you can see that I now export the NFS. I also did an upgrade to NFS 4, because now I can serve it from ZFS, and that way I can see what kind of data the students are actually saving in their home directory, and also how much disk space it takes, and ZFS automatically compresses all that. So we have like home is the home directories for the professors and the employees like me, and they're separate from the students' home directories in case someone else has the same name as the professors and they have their same home directory. Interesting concept. And we have, of course, home data sets that has all these crazy 300 gigabyte JSON files and other things that are needed for the data science environment. And yes, no wrong permissions anymore, because ZFS is understanding everything that the LDAP file server or the LDAP server is telling them about groups and permissions. And I'm super happy now about this file server setup. But there's more. There was no monitoring when I started this big data cluster administration. Well, there was previously a monitoring, but it broke somehow, and they didn't have the time to fix that. So now we have since the file server is now monitoring each individual node, and to make sure that the file server who's running the monitoring isn't going down, I have a little Raspberry Pi running FreeBSD on ZFS that's checking whether the file server is still there, who watches the watchers. And so I get performance data from these nodes, and if a student is making some crazy changes like running a Bitcoin miner, which has happened once, that's probably my talk next year, yeah, then I get the performance data, and I see if a node goes down unexpectedly or if the network is having problems. So that's kind of nice. I'm using Isinga for that. It's not Nagios, but I like Isinga, the things that I saw, and I will probably give a tutorial about Isinga in one of the future BSD conferences. And it's a nice thing because I get a little bit more email this time every morning, because each server is sending me information about how healthy the disks are and what kind of processes we're running and how many students have tried to log into this one, of course futilely. And yeah, this is the actual file server setup that we have and the monitoring that I added to it. And again, it's all, now we have a FreeBSD file server, we have a couple of FreeBSD nodes, like 50% of the nodes are now FreeBSD, and the actual monitoring is redundant with another Raspberry Pi node that is just checking whether the file server is still online. And so in summary, this is where we came from on the right side. We had a desktop image-based node installation with Ubuntu 14.4 with reinstall times of 25 minutes. We had NFS free mounts with some crazy ownership and permission problems. They had back then a little bit of Ansible scripting, like create a user on the file server or create a home directory. Oh, not so much, but it was at least a start. And we had a broken monitoring back then. And now with the FreeBSD setup, we have a fully scripted server-centric installation. We have much lower installation times. This is just getting a coffee on FreeBSD. And Ubuntu takes roughly 12 minutes. I guess I can shave a little bit more on that, but I have to see whether the newer versions, which are probably now with more software that no one needs on a cluster. We also have a ZFS-based NFS4 file sharing server, which provides ACLs and all other things that are interesting in the NFS4 world. I'm playing a little bit with parallel NFS because that's been added to FreeBSD recently, because that might be giving us a bit of performance boost and maybe a couple of redundant file server in case the file server might go down one day. And I have pretty much everything Ansible scripted. So all the Hadoop installations are there, the MongoDBs, the Couchbases that we're using on the nodes. I just have to say, please install this on X machines, and it gets installed. And a couple of maintenance scripts like delete all the users from last semester and, get a new boot environment installed or a snapshot done and things like that. And most importantly, we have a working and redundant monitoring and alerting system that keeps me awake at night telling me, oh, this one machine just went unexpectedly down and it's probably the disk that is 5 years old. Yeah, so in retrospect, it was a little bit sneaky where I introduced FreeBSD, so I didn't actually say, hey, tomorrow I reinstall the whole machine with FreeBSDs, because that wouldn't work. I would have gotten a lot of pushback from the professors who were used to their working environment and didn't want to have to suddenly deal with a new operating system that I've never heard of or I've never used. And so you have to be a little bit sneaky at times and also patient. I mean, this is a process that's been going on for like the last 3 years, and each semester I had a little bit more and more FreeBSD machines in there. And as long as students or users are only using applications, most of them are just oblivious. They don't care what operating system they're running on. There might be different environments, and this is a very unique environment as a university, but I was quite happy, and this is not the end result. The process is still going on as I had to experiment with other NoSQL databases on FreeBSD and seeing what kind of versions are available in ports. Collected a couple of tips and learnings at the end. So as I said, start small and incremental. Don't do the whole exploration step into different environments that you are not familiar with. Start slow, make incremental improvements, and don't do a big bang thing of saying, okay, next week we're all running on a new operating system. Surprise! And also give people the time to experiment with their operating system that they're now being given, or their new way that their home directories are provided, for example. And let them just get a little bit of experience with that, and once they have no complaints, then you can just continue with the next step. Always testing is a big thing. Test everything before you roll it out. So if you're not sure whether things work, test again, test different scenarios. So for example, for the NFS mounts, I not only had to test whether the mount works on FreeBSD, but also working on the legacy Ubuntu systems that we're using. And there were some interesting things coming up, so that also needed to be tested. And write everything down. If you're a sysadmin, you're probably used to that, so making notes about every config file change, everything that you're just doing on the command line, paths that might be different from your other operating systems, any settings that you might do in your loader.conf or rc.conf. All these things might become important when you're doing a new server installation. And back everything up. Oh my God, if I would have lost all these data sets that I used for research, I would have not my head again. So if I lose some of the data that during the process of migrating the file servers, that would not go well with the professors. So that way I backed up everything to multiple nodes to just be sure if one node would die, I still had the data from that. But I would encourage you to experiment, and as long as, we have boot environments, we have all kinds of mechanisms to save our necks, and you never know what comes out of that. If I wouldn't have installed the file server, I would have never discovered the MFI utility and what kind of cool things it provides without going into the BIOS to make changes to any kind of settings for the RAID controllers. And again, don't just do things because you like that operating system of yours. Make sure that you provide some kind of value to your users. Be that they don't have to buy the server hard disks in the next couple of months because you saved a lot of disk space using ZFS compression, or that they are now having the proper files and permissions that they are used to. Small things like that can make a lot of people smile, and your users are happy that you're such a good sysadmin taking care of these systems. Sometimes you have to be willing to compromise, like the systems that I'm running is now doesn't have the ZFS setup that I'm actually initially provided, because that was the research and benchmarking things for the papers that wasn't going to happen. But it's the environment that I'm working with, and I hope that if we don't do any projects with benchmarking, then we're not going to run this other setup. And the rest is just common sense, really. And my time is up, and I guess you have a couple questions. Thank you. We have a couple of things about the cluster here. If you're interested in the hardware and some of the environment, then find that link. Thank you.